derivatives of trig functions. What we are going to talk about today is the derivative of the sine function, derivative of the cosine. We'll look a little bit at simple harmonic motion. We'll talk about the jerk, kind of a cool little thing, and derivatives of other basic trig functions. And we're going to start with coming up with the derivative of this function, which is what function? That is sine. All right, so we have sine of x, and we are going to first graphically look at the derivative of sine. And then we're going to find the derivative the long way. You'll remember on one of our previous quizzes, the bonus was to find the derivative of cosine using the definition of derivative, yes?
Yep.
Well, today we're going to actually show how to do that. We'll do it with sine instead of cosine. And we'll do a couple of the other trig functions as well. So get a sketch of sine on your paper, please. And take a minute and sketch its derivative. Right on the same graph, you can use a different color if you would like. But we're going from f to f prime. And we've done this quite a bit, so take a second and see what that graph would look like. Okay, so let me change colors to, blue is probably a better color actually. All right, and I would start by graphing f prime. No, I'll do it. So my f prime graph will be in green. And f prime has a 0 every place that f has a smooth max or min. So somewhere around here. And somewhere around here. Okay. And then let's look to the left and right. We also would have one. Sorry, I have one more here. All right. So let's start from this 0 to the next 0. Our function, our slope starts at 0, ends at 0, and everywhere in between it is what? Positive or negative? Positive, and the steepest moment occurs when? At 0. So we're going to have something that looks like this. Okay? And then from here to here, starts at 0, ends at 0, our S prime graph does. And all the slopes are negative, with the largest being at maybe pi, do you think? So it's going to come down like this. Sorry, timing out. Good, and back up through here. And then the same thing will happen again. Starts at 0, ends at 0, all the slopes are positive. Biggest one in the middle. Like that. And we'll continue with our last one. It looks like that.
Woo!
So, Calvin.
So the derivative of a sine graph is equal
That is it exactly. So the derivative of sine of x is cosine x. You've learned your first derivative of a trig function. Okay? So graphically we can see that that happens. Now we want to show it algebraically. So now, let's find the derivative of y equals sine x using the definition of the derivative. Your helpful hint is that sine of a plus b is sine a cosine b plus cosine a sine b. We have a couple little reminders of our special limit that you should always look for when you're dealing with trig functions. The limit as x approaches 0 of sine x over x is 1, and the limit as x approaches 0 of cosine x minus 1 over x is 0. Okay? All right, and what we're going to do now is you're going to go line by line. I'm going to pause this. Okay, so I will fill in on this slide our derivative of sin x using the definition as we did on the board. But right now, let's see what I want you to do next. There you go. Now I would like you to do y equals cosine x, very similar to... We should be getting close on this one, and I'll go ahead and start stepping through as you're working at it at your desk. We have the limit as h approaches 0. Cosine of x plus h minus cosine x all over h. We use our sum and difference formulas. And so we get cosine x, cosine h, minus sine x, sine h, minus cosine x. All over h. All right. Then we have the limit as h goes to 0. We're going to rearrange things strategically. This time I see a cosine x that I'm going to be able to factor out. So I'll have cosine x, cosine h, minus cosine x, and then minus the sine x, sine h. All over h. We'll do our little separating. Limit as h goes to 0. And I'm going to factor out at the same time. Cosine x times cosine h minus 1 over h minus the limit as h goes to 0 of sine x times sine of h over h like that. So now we can clearly see our special limit. So when we pull out the cosine x in front, times the limit as h goes to 0 of cosine h minus 1 over h minus sine x times the limit as h goes to 0 of sine h over h. Again, I can pull out the sine x out in front and the cosine x out in front because our variable is h in this limit problem. So the cosine x can be treated like a constant, and the sine x can be treated like a constant. This limit goes to what? 0 minus sine x times what? Times 1. So the derivative of cosine is negative sine. Okay? Yeah. 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 I would. I won't give the special limit, but I would give the sum and difference formula. Okay, so you can give yourself a little note right now. The derivatives of all of these co-functions are negative. Just something to remember. Derivatives of all the cosines, cotangents, cosecants, they're all negative. Okay? All right. Now let's move on and look at another one. Find the derivative of tangent. It says here using the definition of the derivative, but I want to amend that. I didn't mean to say that. I want you to find the derivative of tangent using the quotient rule. Tangent is sine x over cosine x. So do that now, please. We're looking for the derivative of tangent x, which is the derivative of sine x over cosine x. So we will use the quotient rule. Low d high minus high d low. Over the denominator squared. Oh boy. And here is your first reminder. I don't think we've run into it yet. We need to remember that cosine squared x means the same as what? Cosine of x quantity squared. And for most of our processes that we'll do in calculus, the first thing I do is I change it from this form to this form, because it makes it easier to see how to take my derivative and how to move forward. Okay? So that's just a little helpful hint. When you see cosine squared quite often, you will change it to this. On this one, maybe not. So, what do we end up with on top? Yeah, so we'll write it that way now. Cosine squared x, and then what? Yes. All over cosine squared x. And what does the top equal? It equals 1. And what is 1 over cosine squared x? Oh, secant squared. So the derivative of tangent is secant squared x. All right, so we've learned 3 of them so far. Derivative of sine is, what is it? Cosine x. Derivative of cosine is negative sine x, and derivative of tangent, secant squared. Okay. For the sake of time, I will fill this one in. And what I want you to do now is write down the rest of our derivatives. So, derivative of sine with cosine, derivative of cosine with sine. Derivative of tangent is secant squared x. Derivative of secant x is secant x tangent x. All of these are found using quotient rule, the same way we did tangent x. Derivative of cotangent is negative cosecant squared x, and derivative of cosecant x is negative cosecant x cotangent x. This would be a good time to tell you that you will be held responsible without any note sheets for all of the derivative rules that we develop. So you need to know these guys. In some cases, I don't memorize them, I remember how to find them. But all of your trig derivatives, you should just know them. You don't want to take the time to go through quotient rule. These come up enough that you just want to know what they are. All right, and then the other definition we have on this page is the definition of a jerk, which they did have a neat little write-up in the section about this. You know, when you're driving in a car and you step on the brake and you jerk forward. That's it. The jerk is the derivative of acceleration. So you get a jerk when the acceleration changes very, very quickly, instantly. Okay, so it's the instantaneous rate of change of acceleration. So we'll denote it if a body's position at time t is s of t, the body's jerk at time t, and who's that? Denoted j of t, which is the derivative of acceleration, or the third derivative of position with respect to time. Okay, so get that down. I can save my... All right, so you may be asked about that in some of the problems in the homework. There we go, that's better. Okay. So let's see what else we have. So just applying these new rules, let's look at example one. Go back, sure, you bet. Yeah, absolutely. Down the bottom?
Yeah.
Thank you. All right. So now let's look at a few problems. We're asked to find the derivative of x squared sine x. Tell me what we need. Thank you. We need product. All right. Y prime. I'll write it that way this time. Y prime. First times derivative of the second. Would be what? Grace? Help me with that. Shush. Go ahead, Grace. First. Yeah. X squared times. Not that one. Just cosine. Cosine. Yeah. Plus. Sine x. Times. Yep, that's it. And B, u equals cosine x over 1 minus sine x. So I'm going to write it as du dx. I just need to be comfortable with any way of these accepted forms for writing the derivative. What do I need on this one? I need quotient rule, low, high. So low would be what? 1 minus sine x. Be high. Negative sine x. Minus high. Cosine x. Below. Well, derivative of 1 is 0. So what would it be? Negative cosine x. Thank you. Over 1 minus sine x quantity squared. Okay? So you can simplify the top if you'd like, but again, if you're not asked to, you don't have to. Questions on those two? I'm going to throw one more in because people get thrown off when they have to do this. So what if I asked for you to take the derivative of, let's see, can we do it yet? Secant x tangent x.
Well, first,
You could if you wanted to. That would make it quotient though, right? I think we stick with product on this one. We could, absolutely. So 1 over cosine times sine over cosine, and we would have sine over cosine squared, and we would need quotient rule, and we would need product rule in there. So let's just do product rule from here. First times derivative of the second, we get what? Secant x times, not minus, but secant squared x. First times derivative of the second plus the second, tangent x, times the derivative of the first, secant x tangent x. Alright, that'll do. Okay, and then, yes.
If we wrote product rule backwards, would you mind talking about it?
Nope, but I would if you did quotient rule back. Yeah, no problem. If it makes more sense for you to write it the other way for product rule, no problem. All right. So what time am I out? 25? Oh, we have time. All right. Finding tangent and normal lines. Find equations for the lines that are tangent and normal to this graph at x equals 2, supported graphically. All right. First of all, f of x is tan x over x. How do I find f prime of x? Quotient rule, low d high. X times secant squared x. Help me. Minus, that's what I want to hear. High d low. Tan x times 1 over squared. All right, we want a tangent line, so I immediately am going to write y minus blank equals blank times x minus blank. All right, what do I know right off the bat? What goes here?
2.
2, thank you. All right, and how can I get what goes here? Plug into the what last? Into the derivative, so we get 2 times, sorry, my pen is delayed, tangent squared of 2 minus tangent of 2 all over 4. Someone get a calculator out and find that for me, please. Secant is 1 over cosine. I need a value for that. Come on, calculators out, more than one person would be helpful. How do I get the y value that goes here?
Put 2 into tan x.
Good. Put 2 into tan x over x, so that is tan 2 over 2. I'm going to leave it just like that. And this, what is it? 25? Okay. So that's what goes here. All right. One thing I want to make sure is not happening, when you plug into this equation of a tangent line, do not plug in the function for the derivative. Do not leave this all in x's to go in here. We're writing the equation of a tangent line at some point, so you need to plug in that x value to get a number here. Okay, I have some people who like to just toss that in, and it's not enough yet.
Did we toss it 3 times?
You could, but I'm begging you not to, but you could, yes, because any form of the correct answer would be correct. All right, and then quickly let's just get our normal line. Okay, normal line, I warned you from the quizzes that it's to your benefit to leave it in point slope form. So we're going to keep it in y minus tan 2 over 2 equals, what's my slope going to be? Negative 2 times x minus 2. And then we have our normal line. Okay? All right, to the bell. Your homework is on the assignment sheet on the website. We will start reviewing for the test on block day. No.